If you bought a zero-turn mower in the last few years, there is a reason it is not going to last. The manufacturer made one specific decision before that mower left the factory that guarantees it dies before season 4. I am going to show you exactly what they did, which brands are doing it, the only 3 mowers that do not have this problem, and what you can do right now to make the one you already own last longer. Let us start with the business model, because the failure did not begin in an engineering lab. It began in a spreadsheet. From 1980 to roughly 2005, a small engine was built to outlast the machine it was bolted to. Cast iron cylinder sleeves, steel camshafts, all metal governor assemblies, mechanical chokes, simple carburetors with brass jets and replaceable parts. A homeowner who bought a riding mower in 1985 and changed the oil every 50 hours could reasonably expect to mow with that machine for 15 to 25 years. That was the standard. That was the engineering baseline. Then came 2 pressures that converged at exactly the wrong time. The first was regulatory. Beginning in 2011, the Environmental Protection Agency implemented Phase 3 emission standards under 40 CFR Part 1054. These rules required small engines to meet tighter fuel system controls, including sealed fuel systems, low permeation fuel lines, and carbon canisters to reduce evaporative emissions. These were not bad regulations. Cleaner air is a legitimate goal, but the engineering response to those regulations had consequences the regulators did not intend. To meet heat management requirements, to reduce weight, and to hit a retail price point that would move units off a big box store floor, engine manufacturers began substituting glass-filled nylon and sintered plastic composites for the cast iron and steel components that had defined the previous era. The second pressure was financial. In 2020, Briggs & Stratton, one of the largest suppliers of residential small engines in North America, was acquired by private equity. Post-acquisition, the documented pressure was cost reduction and overseas sourcing acceleration. Briggs & Stratton's own annual reports and restructuring documents from that period show the corporate priorities clearly. They call it cost optimization. We call it the systematic removal of durable materials from the only part of a mower that cannot be cheaply replaced, the engine. They call these machines homeowner grade. We call them disposable equipment on a permanent lawn. Here is the economic logic that drives the entire system. A plastic camshaft and governor assembly cost the manufacturer meaningfully less per engine than an all-metal equivalent. Multiply that across hundreds of thousands of units per year, and you are looking at tens of millions of dollars in annual savings on the component that will determine whether your mower lasts 3 years or 15. That is not an engineering trade-off. That is a calculated decision about whose problem the failure becomes. And the answer is always yours. The result is a consumer zero-turn mower that retails for $2,800 to $5,500, reaches a critical failure threshold between 200 and 400 hours of use, and then presents you with a repair bill that is 60 to 70% of the cost of a new machine, making replacement economically rational and repair economically irrational. That is not a coincidence. That is the cycle. But the business model is only half the story. The other half is inside the engine, and that is where the real damage is happening. Let us open the crankcase. When your zero-turn mower surges at idle, when the engine hunts up and down in RPM instead of holding steady, most homeowners assume it is a carburetor problem. They clean the carburetor. The surging continues. They rebuild the carburetor. The surging continues. Eventually, the engine loses power under load, starts hard in the morning, and then one day does not start at all. That is not a fuel problem. That is a camshaft problem. Here is what is happening inside the crankcase of a Briggs & Stratton 40R or 44R series engine, and inside a Kohler 7000 or 7500 series engine manufactured after approximately 2015. The camshaft is the component that controls valve timing. It is a precisely machined shaft with lobes that open and close the intake and exhaust valves at exactly the right moment in the engine's firing cycle. In the engines that preceded these models, the cast iron Briggs and Vanguard series, the pre-transition Kohler Command series, that camshaft was machined from hardened steel or cast iron. It was designed to survive thousands of hours of continuous thermal cycling, vibration, and oil-lubricated contact stress. In the current consumer-grade engines, that camshaft, or the gear-driven components connected to it, is now made from glass-filled nylon or a composite material. People spend a whole season chasing one mower problem across a dozen forums and YouTube videos and never find a straight answer, because the real know-how is scattered in 100 pieces, and half of it's wrong. A mower that lasts isn't built different, it's maintained different. The new Make It Last maintenance protocol puts the whole thing in one place. What actually kills these mowers? How to spot trouble in your engine before it dies? What's worth fixing? And which parts to buy without getting jerked around at the dealer? Walk behind or riding, there's one for both, plus a printable maintenance calendar in every book. Scan the QR code or tap the link up top, code MarkTalksQuality for 15% off. Make it last. The Governor Assembly, which regulates engine speed under varying load conditions, contains plastic weights, plastic gear teeth, and composite components that were never designed to survive the thermal cycling that a small air-cooled engine generates across a full mowing season in a southern climate. The failure mechanism is straightforward. Thermal cycling, the engine heating to operating temperature and cooling between uses, repeated dozens of times per season, causes the plastic components to expand and contract at a different rate than the surrounding metal. Over 200 to 400 hours of operation, the gear teeth wear. The governor weights lose dimensional accuracy. A tooth shears. The governor can no longer regulate engine speed. The engine surges. Then it stops governing entirely. Then it stops running. The repair requires either a full short block replacement, the lower half of the engine containing the crankshaft, camshaft, and cylinder, or a complete engine swap. Either path costs $800 to $1,500 in parts alone before labor. On a mower that cost $3,000 new and is now 3 years old, the dealer's quote for repair will be $1,200 minimum. A new mower costs $2,800. The math is designed to make you buy another mower. And the new mower has the same plastic camshaft. That surging RPM is not a tuning problem. It is a terminal diagnosis delivered by physics, scheduled by the manufacturer, and paid for by you. Now, let us talk about the second layer of failure, because the plastic camshaft is not the only thing working against you. While the engine's internal components are failing by design, a parallel set of failures is occurring through neglect of systems that require active maintenance. These are not manufacturer sins. They are homeowner vulnerabilities that the modern engine's narrow tolerance for poor fuel quality makes dramatically worse than they would have been 20 years ago. Start with fuel. Gasoline degrades. That is not a theory, it is chemistry. The lighter hydrocarbon fractions in pump gasoline begin evaporating within 30 days of purchase. The heavier fractions oxidize and form varnish and gum deposits. Ethanol-blended fuel, which is nearly universal at American gas stations, accelerates this process because ethanol is hygroscopic. It absorbs atmospheric moisture. In a humid climate, fuel sitting in a mower's tank and carburetor bowl through a winter storage period will have absorbed enough moisture to form a phase-separated mixture that corrodes aluminum carburetor bodies and clogs the needle valve and emulsion tubes with a tan, waxy residue. Your grandfather's Briggs and Stratton from 1988 had a simple float bowl carburetor with large jets and a manual choke. You could clean it with a can of carburetor cleaner and a straight pin in 20 minutes. The modern consumer carburetor on a 40R engine has smaller passages, an electronically controlled automatic choke, and pilot circuits that clog with residue that carburetor cleaner will not dissolve without disassembly. The fix is not complicated. Use ethanol-free fuel whenever it is available. Your local marina almost certainly sells non-ethanol premium gasoline. Add a quality fuel stabilizer, a real stabilizer with antioxidant chemistry, not a gas line antifreeze. Anytime fuel will sit in the system for more than 30 days. Before storing the mower at the end of the season, run the engine until the carburetor is fuel dry, not just turn-off dry. Run it until it stalls dry. That is the only way to ensure no residual fuel deposits are curing to varnish inside the carburetor passages over a 5-month winter. This is not complicated maintenance, but in the pre-EPA transition era, it was largely optional. Modern engine tolerances have made it mandatory. Now move to the air filter. The zero-turn mower operates in some of the most demanding air quality conditions of any small engine application. Grass dust, lawn debris, fine soil particles. All of it is drawn toward the engine's air intake by the cooling fan. The air filter is the only barrier between that debris and the carburetor's precision passages and the cylinder's piston rings. A clogged air filter does two things. First, it richens the fuel mixture. The engine gets too much fuel relative to available air, which causes black smoke, fouled spark plugs, and carbon buildup on the valves. Second, if the filter is degraded enough that debris passes through, it causes abrasive cylinder wall wear that will shorten engine life faster than any other single factor. The research is clear. Clean or replace the air filter every 25 to 50 hours on a residential mower. For larger commercial grade units, every 100 hours. For a homeowner mowing a 2-acre lot weekly, that is probably once per season at minimum, and twice if the property has dry, dusty conditions. The spark plug is the ignition system's weak link, and it is also the cheapest component on the machine. Inspect it annually. A worn plug with a gap that has drifted from specification causes hard starting, misfires under load, and increased fuel consumption. A fouled plug with carbon deposits on the electrode tells you something else is wrong. Either the air filter is compromised, the carburetor is running rich, or the engine is beginning to consume oil. A new plug costs $4. A fouled plug that goes undiagnosed for 2 seasons costs you the wear it hides. Change the oil every 50 hours. Air-cooled small engines run hotter than water-cooled automotive engines. And that heat degrades oil faster than the hour meter suggests if you are mowing in 90-degree summer heat. Used oil is not just less lubricating, it is acidic. Extended oil drain intervals on an air-cooled engine with plastic valve train components are exactly the kind of accelerant that turns a 200-hour failure into a 150-hour failure. Keep the cooling fins clean. Every small engine has cast aluminum cooling fins on the cylinder head and block that dissipate the heat the air cooling system generates. Grass clippings pack into those fins during mowing and act as insulation. A blocked cooling fin array can raise cylinder head temperature significantly. On an engine that is already running at the upper boundary of its thermal design, particularly on a hot July afternoon in Georgia, that additional heat is the difference between normal operation and the accelerated plastic component degradation we described earlier. Clean the cooling fins with compressed air at the beginning of every season and inspect them after every few mowing sessions during heavy grass growth periods. Now, let us talk about what happens when you try to fix any of this yourself, because that is where the second trap is set. Here is the part of this investigation that should make you genuinely angry. When the plastic camshaft components in your Briggs & Stratton 40R engine fail, the logical repair is to replace those components. In an engine designed for longevity, you would order the camshaft, the governor gear, and the governor assembly as individual components, do a crankcase split, and rebuild the engine at the component level. Total cost in parts, maybe $80 to $150. Total time with basic mechanical knowledge, 3 to 4 hours. That repair is frequently not available to you. On many current consumer-grade engines, the plastic camshaft and governor components are not sold as individual replacement parts. They are only available as part of a short block assembly, the entire lower engine, cast, machined, and assembled at the factory, with a price of $600 to $900 before labor. The component that failed because it was made of plastic costs a fraction of what it takes to replace it at the minimum serviceable assembly level. The difference between those two numbers is a repair barrier that was engineered into the parts supply chain as deliberately as the plastic was engineered into the engine. Some sealed crankcases on current consumer models cannot be split without proprietary tooling. EFI, electronic fuel injection, versions require dealer-level diagnostic equipment to access fault codes and recalibrate the fuel system. Parts for many consumer-grade models are discontinued within a few years of the mower going out of production, which means a mower that fails in year 4 of a 7-year production run may have no available repair parts by year 9. This is not parts scarcity caused by supply chain disruption. This is a designed repair ecosystem that makes maintenance economically irrational and replacement economically necessary. The industry documentation is clear. Dealer-only parts distribution, sealed assemblies, proprietary diagnostics. And these are not engineering necessities. They are business decisions. The right to repair movement exists for a reason. That reason is sitting in your garage with a surging engine and a dealer quote that is 70% of the cost of a new machine. They call this the replacement economy. We call it a $4,000 piece of equipment engineered to become landfill in 5 years. But before you conclude that the entire category is hopeless, understand this. The problem is not zero-turn mowers. The problem is a specific tier of zero-turn mowers using a specific generation of cost-reduced engines. The commercial-grade market has not followed the same degradation path, and that distinction is the most important purchasing intelligence we can give you. Let us talk about what you can actually do. If you're in the market for a zero-turn mower and your goal is to own one machine for 10 to 20 years, there is a clear path. But it requires rejecting the big box consumer category entirely. The commercial grade zero-turn market, brands like Exmark, Skag, and Wright, uses fundamentally different engine and drivetrain specifications. The engines most commonly found on proven commercial units are the Kawasaki FX series and the Honda GX series. Both use cast iron cylinder sleeves, steel camshafts, metal governor assemblies, and valve train designs that are documented to survive 1,000 hours or more of continuous commercial use. These are not marginally better than the Briggs 40R. They are architecturally different machines designed for a different durability standard. A new commercial grade zero-turn will cost $6,000 and up, with professional tier machines from brands like Skag, Exmark, and Wright commonly reaching $10,000 to $20,000 depending on deck size and configuration. That number is the beginning of a 10-year cost analysis that the consumer market is hiding from you. Run the numbers. A consumer-grade mower at $3,500 replaced every 4 years as the failure cycle demands costs you $12,000 to $18,000 over 20 years, not counting the repair attempts before replacement, not counting the disposal costs, not counting the dealer labor on the final diagnosis. A commercial grade mower, maintained properly, running for 15 to 20 years, costs you far less over 20 years plus routine maintenance. The commercial unit is not an upgrade. It is a financial decision. If a new commercial unit is outside the current budget, the used commercial market is one of the best values in outdoor power equipment. A 2010 to 2018 Exmark or Skag with documented maintenance records and under 1,000 hours on the meter, verified by the hour meter and confirmed by a used equipment inspection, will frequently outlast a new consumer-grade unit purchased today. Budget $2,000 to $4,000 for a quality used commercial unit, and you are buying a machine with a Kawasaki FX engine that has engineering on its side. If you already own a consumer-grade mower and you are not replacing it yet, you are not out of options. There are 6 specific maintenance steps that will push a consumer engine past the failure window the manufacturer designed into it. The intervals are not what your owner's manual tells you. They are shorter, they are specific to the engine type, and they address the exact failure mechanisms we just walked through. The complete maintenance protocol, every interval, every product specification, every seasonal procedure is compiled in the field reference linked in the description. That protocol is the difference between a mower that dies at season 3 and one that makes it to season 8. If your mower is already surging, hunting RPM at idle, losing power under load, do not wait for complete failure. Have the carburetor cleaned and the governor system inspected by a qualified small engine technician before you invest further in the machine. That inspection will tell you whether you are dealing with a fuel delivery problem, which is maintainable, or a plastic camshaft failure in progress, which is a replacement decision waiting to happen. When you do buy your next mower, inspect the engine specification before you look at the deck size or the cup holders. Ask the dealer directly, what is the camshaft material in this engine? What is the governor assembly made of? Are the internal components available as individual replacement parts or only as short block assemblies? If the dealer cannot answer those questions, find a dealer who can. Demand a Kawasaki FX or a Honda GX engine. Demand cast iron cylinder sleeves. Demand a valve train you can see documented in a service manual that lists individual components with individual part numbers. If the manufacturer will not sell you individual internal components, they are not selling you a mower, they are selling you a countdown timer. Document every maintenance interval in writing. Not because you enjoy paperwork, because warranty disputes require documentation, and resale value depends on a maintenance history that is verifiable. A used mower with a logbook is worth more than the same machine without one. A warranty claim without documented maintenance intervals is a claim the manufacturer will deny at the first opportunity. Here is the verdict. From 1980 to 2005, a small engine was a metal machine built to outlast the person who bought it. It ran on simple chemistry and mechanical tolerance. It could be repaired at the component level by anyone with a service manual and a torque wrench. Its parts were available for 20 years after production ended. It was built on the premise that the buyer's money deserved a machine that would last. What replaced it is a machine built on the premise that the buyer's replacement cycle is a revenue stream. $8 worth of composite material where a steel camshaft used to be. Sealed crankcases where a serviceable engine used to be. Proprietary diagnostic tools where a carburetor adjustment screw used to be. Parts discontinued at 5 years where availability used to run 2 decades. This is not engineering progress. This is the same hollowing out that happened to home construction, to consumer appliances, to every durable good category where a publicly traded supply chain discovered that selling you 3 products over 20 years is more profitable than selling you 1 product that lasts 20 years. You are not a lawn care customer. You are a replacement cycle. Stop buying the machine with the lowest sticker price. Start buying the machine with the lowest 20-year total cost. Stop trusting the big box floor display. Start reading the service manual before you sign the receipt. Stop accepting homeowner grade as a category. Start demanding commercial specifications for a commercial task. Your property deserves a machine built to maintain it. Your investment deserves an engine built to last. And the industry deserves a customer who knows the difference between a 3-year countdown and a 30-year tool. Build the maintenance log. Buy the commercial engine. Know what is inside the crankcase before the crankcase is sealed, because physics does not negotiate, and neither should you.